Lewis, I'll hand over to you. So everyone, this is Lewis from Niryo in France, and he's going to run us through our webinar today. So yeah, thank you for jumping on and joining us today.
Thank you, Sam, for the introduction, and thank you for letting me hosting this webinar. It's always interesting and fun to see that I'm here in France. You guys are all the way back in the other side of the world, and we're still here together to talk about our robots and robotics in general. So yeah, what I did is that I prepared some slides for us to go through to present a bit more of the products that we have at Niryo, who we are. I'm not sure if there's anybody in the audience that is already customer. Maybe it's our old robot, maybe it's our new. Just let me know in the chat if you're already familiar with some of our products, or if this is really brand new. It's first introduction to Niryo for you guys. So let me just share my screen and start the presentation. There you go. So like I said, yeah, we're nice. Niryo. Oh, all right. Yeah, I think there was a bit of issue with the connection here. And by the way, let me know in the chat if there's any questions when there's a slide. If you're not familiar or not understanding what I'm talking about, it may happen. I hope you can understand my accent as well. Normally, it's not that French, but if there's any issues with understanding, let me know. So Niryo is a French company based in the north part of France. So we're like you may know, French manufacturers of collaborative robots of 6 axis. Robot right here, built for the education, built for the transition between the industry 4.0 to the industry 5.0. So we'll get back to that industry 5.0 a bit later if you're not familiar with the concept. But yeah, like I was saying. Because we take part in the development of the French industry, it was really important for us to have everything, all the development here in our headquarters based in Lille. That's very top, very north of France. I don't think you can go more north than Lille. So if you want to look on the map, you can see where we are. Like I was saying, so Niryo is still a startup. So even though we're a pretty small company, at our scale, we're already 40 employees, which is a big increase in the last year. So I've been here personally for more than a year now. When I got here, we were like 25 employees. And so we've been employing a lot for the past year, really developing. 2/3 of these employees are in research and development. The goal is, because we're in an industry, because we're in the field of robotics, where technology is always important to improve, and we always have to be at the tipping edge of technology. 2/3 of the employees are in research and development to constantly increase and to increase the quality of our products. Like I said, made in France, based in France, manufactured in France. That's a real good aspect for us. And in terms of selling the robot, it's important as well to put in favor the French quality on this. So we've sold more than 2,500 robots in the past. Well, that's 4 years now. So we were created actually in 2016. But the first robot came out in 2018. I'll come back to that right after this slide to tell you a bit more about the history of our robots and in which order they came out. So yeah, for the past 5 years now, 4 or 5 years, we've been manufacturing and sold over 2,500 robots, and that's more than 60 countries in which we sell. So in terms of percentage, that's about 70% of the total robots sold on the international scale. So this goes with, well, distributors, partners like the Brainary that really help us to be present in certain countries, certain area of the globes that is impossible for us with our 40 employees to really touch. So it's important that we have long-lasting partnerships and ambassadors that really represent the brand, that represent Niryo abroad, and in this case, in Australia, New Zealand, and even further. So just to give you a quick history of the robots. So the first one came out, like I said, in 2018. So there was 2 years before that really developing. It takes a lot of time to manufacture and really get to have a product, a final consumer good product that's ready to be used in the field of education. So Niryo 1 was our first one. As you can see, there's a huge difference with already the second one, which is Ned, that you can see in the middle. So that one came out last year, and the goal was really to to get the feedbacks from our customers, from the end users, and constantly we'll take what they have to say to increase and to really improve the quality of our products, both in terms of software, because we also develop the software. I'll come back to that right after, but also in terms of hardware. And so, well, the quality, the robustness of the robot. And this is a word that I want you to keep in mind. It's really the robustness that we are working on, and the capacity really to be long lasting for the teachers to be able to use in their schools, in their classrooms every day. So Ned this is 3D printed material for Niryo 1. This is also 3D printed material for Ned, but we reworked on the motors, so the stepper motors that we have, the DMXO motors as well, constantly improving on the grippers, so the end effectors that you can see here also. And we really worked on the aluminum structure to make it more robust and to make it more living, so last longer in time for teachers really to be able to enjoy during the whole year, the whole semester for teaching their classrooms. And then early this year, so 2022, we once again continued improving the quality of our robot, and we came up with Ned2, which is the last little baby that we created here at Niryo, and once again working on the quality of the materials. So this is now plastic injection. So we kind of got rid of the 3D printed, although it was a pretty good material in terms of quality, in terms of design. It looked better to work with plastic injection. And then after, we added a bunch of new technology on this that we'll have the opportunity to talk about during this webinar. But yeah, in general, really work on the physical aspect of the robot for it to be more good looking, and really to have the quality and the robustness that we want. So like I said, yeah, we have two business units here at Niryo. First one is with this robot is the education. So really to target teachers, and then to teach, to experiment, and to prototype the industry 4.0, now going towards the industry 5.0. So that's one business unit. And the other is the professional offering, so more towards the industrial one. So the goal here, so it's still under development, but to give you a little peek into the future, we're looking to develop some semi-industrial robots, really to have the same DNA as this one, but to make industrial robots that are more compact, that are more fitted to some use cases that are not for the moment fulfilled with the industrial robots that are available today. So if we look a little bit at the educational part of our robot, so with Ned2 now, 76% of our sales are for higher education. So that goes with universities, technical schools, high schools, even younger users, depending on the country. I know in France, for example, we're quite late to getting there at the robotics world into younger age, but more and more we're seeing high schools using and teaching robotics, really to give them an early sense of using those robots that they'll find in the world of tomorrow in the industry, for example, if they want to work in that field. So that represents, 3/4 of our sales, and the other 1/4 is for companies. So to help them to prototype, to do some demonstrations, if they want to go in trade shows, for example, and show what kind of a use case that they want to implement in real life, but they don't have the space really to show to the world what they want in that trade show. Well, they use smaller robots, more compact robots like ours, to demonstrate what they're willing to do at a bigger scale. And also research and development. So we work a lot with labs also that use our robot to do basic research and development prototypes. So these are some of the notable international universities. We have a lot of others. These are some of the main ones that we worked with. I'm not going to go through all of them, but these are some good universities that are always nice to talk about, which we have use cases from. Then we have some international companies. Like I said, 1/4 of our market is working with big companies. So these are French, but also international ones. And they all have kind of their whole history. They all have their way of working with our robots. So it's always interesting for us to get their feedbacks and to see what they use and how they use our robot in their world. That is quite different than the educational world that we're used to working. So if we dig into the core of the subject, it's of course the products that we develop, that we propose to the world of the educational world. So we develop a complete ecosystem to really fulfill the needs of the professors in terms of teaching the industry 4.0 at school and really understanding how robotics work. So it starts with like I said, Ned2 with our latest robot. So it is designed for education, research, and prototyping. We really want to work on the fact that it's affordable. So it's way cheaper than the ones that you'll find in the industry. Of course, it's not the same needs, but those on the industry are so expensive that it's hard for professors sometimes to really get a sense of how they can implement that in their classrooms. So this is where Niryo has taken a huge part in the positive way, because they want really to work on the fact that they are, and to play on the fact that they're affordable for teachers to be able to have more than one, for students as well to be able to use them in class directly. And also we want to work on the fact that it's easy to apprehend. We'll see right after this slide how it is to easily use and to understand robotics thanks to Ned2. So it's based on open source technology. Once again, it's to go further for professors. So like that, they're not limited to just what we develop, but they can go further if they want to in their educational in their classrooms. So yeah, like I said, very important to work on the robustness, on the quality of our products, on the quality of our robot. So we redeveloped the aluminum structure to make it really robust and make it. Well, it's a robot that you move around from a classroom to another, and probably from a school to another if that's what you if you teach in multiple schools. So it's important for it to be moved easily and not to be fragile, to be able to reuse it in another school or another classroom. So this is why we really worked on the new materials and constantly making it more robust for it to be moved around, but also to last longer in terms of the functioning of the robot. Like I said, the team is growing more and more. So now we have the capacity, and we have the number of employees we need to be able to test and to go further to testing and to improve all the repeatability and the accuracy of our robot. So now we can say that our robot has a repeatability and accuracy of 0.5 millimeters, and that's everywhere. So that means if it goes to maximum reach, if it goes all the way there, then we'll have the same efficiency and same accuracy and repeatability. Then if it is really close to the base, which is easier for the motors because they're needing less force. But yeah, it was important for us to really work on the efficiency of the robot. For those that maybe know and have already used the Ned robot before, so that was the second version of a robot. It was a great little product, but in classrooms, it made a lot of noise because we didn't have the stepper technology that we have today. So if you're using 10 robots like some teachers do in our classroom, at the end of the day, well, you're quite happy to trim them off. So we really work on the silent part of these stepper motors to be, like the name says, it's more silent and to make zero noise. So now they functionate and they move with very few noise, and it's easier for a teacher to teach in that environment than in a noisy one where the robots made before a bit too much noise. One of the aspects that we developed as well with this new robot with Ned2 is the redesigned human-machine interaction. So the capacity that the robot has to will send signals to the user, to the human. So we added an LED ring that you can see at the base right here of the robot in blue here on the picture. This is, to give signals to the users. So you don't have to go look into the software, what's going wrong with my robot, what is happening. You just have codes that you predefined before. So let's say now it's blinking in orange. Maybe it means that you're out of bound. So the robot is out of the of its original status, or if there's an issue, if there's something that it bumped into something, you can make it red. So like that, you already know directly what signals the robot is sending to you. And also we added speakers that goes in the same way, really to help the user understand what's going on. but you can go further, put music into the, it's kind of a, yeah, I said that working into a silent environment, but you can also add some music if you want the robot to work and to do its use case with some music, if that's what you're looking to as well. Really the capacity to go further, and that goes with the human machine interaction that we redesigned to make life easier for the user to handle Ned2. There's also a control box. So we saw Sam had his camera earlier, and we saw the little setup that he had. There's a control box that I don't have right here, but it's really to if there's an issue, an emergency stop button. This is something that has been asked since the first usage of our robots, in case, yeah, there you go, Sam, thank you very much. In case there was an issue in the classroom, a student has his finger, I don't know, stuck. Normally it's impossible to get your finger stuck because we redesigned everything. But in case you really need, there's an emergency stop button. And last but not least, so we're based on Raspberry Pi 4. So that's in terms of inside what's the robot. So we're based on ROS, and inside is a Raspberry Pi 4. All of our robots before were based on ROS, and we're based on Raspberry as well. So it was important for us to continue on that path. It's compatible with Windows, Linux, and Mac, so that's not an issue if you want to use whatever computer you want. And like I said earlier, so we're affordable in terms of price and also accessible in terms of usage, and that goes with a wide range of programming language. So it goes from the easiest one, which is Blockly. So like I said, we develop our software and it's based on Blockly. It's a bit like Scratch. I don't know if you know what it is. Let me know in the comments if you're familiar with Blockly or not. But it's really the easiest way you're gonna learn robotics. It works with little blocks that you add up. You take the position, save the position, press play, and it will run the program automatically. And then after, it gives you the possibility as well to be communicated through Modbus, MATLAB, Python. And if you want to go further, C++, and of course, communicate through ROS. So like you find in the industry of tomorrow, there's a lot of different end grippers that you can work with on a robot. So it goes with the basic one, which is custom gripper that is sold with the robot, by the way. So you don't have to purchase that. Additionally, it is really sold. It comes with the robot. This custom gripper actually gives you the possibility to 3D print your own jaws. So as you can see here, the edge, well, really the jaws of the gripper is 3D printed. So we can give you the STL files thanks to our GitHub, and you can of course, well, print your own jaws and really create your own use case using your own gripper. So that's a pretty sweet aspect of our robot, thanks to a 3D printed material. Then we have a large gripper, which enables you, like the name says, well, to grab larger objects, and an adaptive gripper if you want to, for example, grab a can. This one will go around it and really get the totality of the object and trying to surround it as much as it can. And then after, you have, of course, electromagnets that you find in the industry of tomorrow with industrial robots, and a vacuum pump that use suction really to will do pick and place with the suction technology. One of the things we developed, and an aspect that was important for us to really redesign and to rethink, was the capacity to connect the grippers. So now it's magnetic easy connect system. So all you have to do is really stick it in, and it will automatically stick with the magnet functionality. Before, we just had a tip that you put in that wasn't, I mean, it worked very well. Don't get me wrong, but it was just not as reliable. I mean, if there was something stick inside, then it wouldn't fit as well. So now, thanks to the magnetic, it's really easy to use. You can also, we'll see what's inside. So if there's something that's going wrong, you can, I mean, if there's something stuck in there, you can get it out easily, whereas before it was a bit harder. So really redesign the efficiency and the easy aspect of using the robot is what we put forward into this Ned2. And also, as you can see on the side, we worked on a control panel that is now on the wrist of the robot. So Before with Ned, we didn't have any, we were constantly in free mode. So that means that the robot had no motor resistance, no torque resistance. So now once the robot is turned on and is ready to be used, it has motor resistance. So that means you can't move them around. The motors will be functioning and you can't move the robot around because it will be, well, under torque resistance. So now what we did is that we added a free motion button. So all you have to do is stay pressing the button, and then you're able to move the robot with one hand, whereas before you had to use two hands and trying really to be more accurate. So now if you want to stick this position, all you have to do is let go of the button and it will automatically activate the motor resistance and not move. So that's easier for students to go get their positions when they're using Blockly, for example. And yeah, it makes the interaction a bit better than having to press on the computer to activate and deactivate the free motion technology that we had on the previous robot. There's also a save position button. So this gives you the possibility, well, you do use the free motion and you want to save, all you have to do is press the button right next to it. So this would automatically save the position. So there's 6 axes and it will save the exact position of all the axes for the robot to go back to the position that you saved. And then there's the custom button. This is like its name says, it's the button that you use to put whatever you want. Here at Niryo, by default, it is on open and close gripper to help during use cases when using Blockly. But you can really use the button and program it as you like. If you want to press custom to, I don't know, do a calibration or change the color of the LED ring or to add music to your program, this is all things that you can use with the custom button. So like I said, a complete ecosystem, really the goal is to come close to what you'll find in the industry of tomorrow, in the industry 4.0 and go towards the industry 5.0. And so that goes with the vision set. So this is a little camera that you have at the edge of the robot, like you can see on the slides. So this is what we like to call a dynamic camera. So it's not a camera that's facing outside the scene really and just facing a workspace and functioning with the robot, with the camera being outside. It's really on top of the robot and it moves, all the movements are with the robot. So this allows you to go further into well, image processing, machine learning, and of course, artificial intelligence, in which we have some use cases that we'll show right after this. But yeah, the goal is really to use and to work on the image recognition of, well, our camera is with image, so shapes and colors on the workspace. It's able to recognize shapes and colors to really do a pick and place automatically given those shapes and those colors. So for the artificial intelligence here at Niryo, we work with TensorFlow. I'll get back to that right after. And then last but not least is our Conveyor Belt. So once again, the goal is to really get what you'll find in the industry of tomorrow. So that's a Conveyor Belt to reproduce all the production lines, so prototyping production lines at a lower scale. Yeah, you can control it through multiple aspects. So you have a control box outside that Sam also has. It looks like the emergency button that we had for Ned, but it works with the Conveyor as well. There's a little, how do you call that? A little button to increase and to decrease the speed, to move it forward and to move it backwards. So you can use it without really connecting it to the robot and use it apart. But you can also use it through Niryo Studio, through Python with Niryo. You can use it through an Arduino. Really, there's a wide way to control this Conveyor Belt. And as you can see, there's some tips here directly. There's some marks on the Conveyor Belt, and the goal is really to enable the customers, so enable the teachers and the students that will use this ecosystem to use both, the robot, the camera, and the Conveyor Belt at the same time. So these little landmarks that you have right here are for the vision set to be able to operate directly on the Conveyor Belt. And there's also an infrared camera. When there's an object that goes through, it just stops automatically. And we also work on the efficientness of the robot to really functionate, well, to make it easier to work and to live with the robot. So now there's a magnetic magnetic system. It's really easy. You just stick it on there and take it off. Whereas before we had to take a screwdriver and screw the landmarks on there. So now it really worked on the easy way to functionate with the conveyor belt, the robot, and the vision set all together. So like I said, Niryo is both a robot designer, but also the software that goes with it. So this is Niryo Studio. So this is the software. This is the interface that we've been developing with our robot, around our robot. So like I said before, it's based on Blockly. So for those of you that are not familiar with Blockly, it's a bit like Scratch. You can see a little example right there that's going through. So we work with little blocks that are predefined that we've already constantly working on to develop. Then all you have to do is just take the position you want on the robot, press the save button, and a little position with all the X's that you can see here in blue will appear. You just add them up, and then after press play, and it will automatically run the program. So it's a very easy, a very efficient way to learn programming and to learn well how to functionate with a robot directly with our Niryo Studio. There's also the capacity to see if there's an issue, the status, the updates, to program the conveyor, like I said before, and also the vision set. So this is where you'll have all the information of all the ecosystem of Ned2 directly on Niryo Studio. And by the way, it's also free. You don't have to really own the robot to be able to download this. All you have to do is go on our website. There's a download area. You can download this. Of course, it won't work if you don't have a robot, but you can already see the interface, see a little bit how it works, and you can already have a good idea of the blocks that are available for your students if you're looking into purchasing robotics equipment for your classroom. So you can already have a good insight, a good vision of what we do on Niryo Studio with Blockly. Once again, on our website, so this is where you download the Niryo Studio, but there's also a wide online documentation that's available for all the different aspects that you want to go through, all the different course materials. We're constantly working on tutorials, really, and curriculums to really help the teachers to implement the robotics course and to teach the robotics for their students. So yeah, this is something we're constantly looking to improve. We're constantly looking for new content to put online. Recently, we did like you can see on the image on the left, a lot of tutorials on MATLAB. We've developed this. This was something that was asked from teachers all around the world. So we worked on this to come up with a tutorial to be able to be taught in class. So yeah, there's a lot of different things. You can see everything online. Everything is for free, downloadable for free. So I encourage you after or during this webinar, if you want to have a look at all the documentation, all the tutorials that are available online. And part of the process of increasing the team and having a team that's been bigger and bigger for the past year is, well, to try and develop curriculums and to help professors in their quest of developing course materials. I know it's not always the easiest thing. So yeah, the team is growing, and the goal is really to come up with new ways, new curriculums, new tutorials of robotics and around our Ned2. So also we have a YouTube page. So this will give you as well. So you can find everything on our website. There's also a YouTube page with a lot of different use cases. So it goes from prototyping, production lines. So this is a use case that was done by a famous school here in France called Make Avenir, IT2I. So it's an engineering school, and they reproduced a production line of pencils. And so the goal was to separate the class in two, give them 5 robots in one group, 5 robots in another group with conveyor belts, and to develop a whole production line all the way to the end, where they had to use artificial intelligence to recognize the color of the lid and to place this in the correct bin for it to be dispatched afterwards. So once again, a great tutorial to learn modeling, automation, image processing, and IoT. And then to go further, there's a lot of other use cases. I'm not going to go through all of them, but yeah, we've been working a lot with a company here called Alten. They're working a lot with digital twins. They do a lot of work. I encourage you to go watch online what they have to propose. They work a lot with artificial intelligence as well, and voila. And then the last use case is some of the prototyping that we have from companies. Like I said, 24% of our customers are companies, and they used. So this is the example of a company that sticks stickers on small mechanical parts, and before that, they have to use big industrial robots for just a little task like this. And so they used our robot to show and to prove that you can use actually smaller robotics equipment to stick, well, to do a plain simple pick and place with suction pump, with a vacuum pump, and after the capacity to have, there's a little roll up on the gripper, the yellow part, so it just rolls up to stick really the sticker. And to give you a good example of what can be done with a robot, and to prove actually that you don't need big oversized robotics, industrial robots that cost a ton to be able to do some small use cases like this. And of course, the tutorial of MATLAB that I talked to you about earlier. So once again, I encourage you to, if this is something you're looking into, developing use cases around MATLAB and using MATLAB and teaching MATLAB, I encourage you to go watch online what we have. And like I said as well, TensorFlow. A lot of professors use this to develop, use our robot to develop artificial intelligence and to work with artificial intelligence thanks to the camera. So you have a couple of tutorials using TensorFlow, but more. There's also a professor from a school here in Lyon that used our robot to play the game Connect 4 using artificial intelligence. So once again, I encourage you to go watch this online. It will show you, it will give you a good example of what can be done with our robot using that technology. So that's about it for my presentation. I went through a lot of different subjects. I'm not sure if there's any questions, but if there's any, I'd be happy to answer to them. There's a lot of videos. This is the video where you can discover Ned2, the products that we develop. So I encourage you once again to have a look on our YouTube page.
Thanks, Lewis. Really appreciate you going through Ned2 and giving us a good background on Niryo and where everything's come from. What I'll do now is I'll just stop our recording and open it up to anyone who's got any questions about Ned2. So once I stop that recording, you're welcome to switch on your mic and ask any questions.